Hello, this is Mr. Henry, and welcome to lesson 2.4. This lesson is on multiplying real numbers, which are fractions and decimals, whole numbers, positives, negatives, everything. Okay, so let's get started with our get the goofs here. First problem says 1 minus a negative 5, which if you use KFC becomes 1 plus a positive 5. And 1 plus 5 is just 6. Number 2 would be a negative 5 plus a positive 2, and the signs are different, so we subtract, keep the sign of the bigger number, a negative 3. Number 3 here is way wrong because they didn't find common denominators. The common denominator of 3 and 7 is 21. This fraction you take times by 3 because 7 times 3 is 21, 1 times 3 is 3. This fraction we take times by 7 and get 14. Don't forget about your signs. There's the negative, there's the minus. We could do a little KFC. So a negative 14 over 21 plus a negative 3 over 21. The signs are now the same. So we add them together, and 14 plus 3 is 17 over 21. Keep the sign of the bigger number, negative 14 over, or negative 17 over 21. And the last one here, number 4, says negative 3.2 plus a negative 1.5. The signs are the same, so we add. So 3.2, 1.5 adding together gives us 4.7. So I'll agree with the 4.7, but we have to keep the sign of the bigger number, which makes it a negative 4.7. All right, so one vocab word, the multiplicative identity, which I told you was going to happen way back when we were talking about addition, how those same properties apply for addition and multiplication. So there's a multiplicative property of an identity. So what that means is if you take any number, for example, negative 3 or 5, and you take it times by something, you get that same number back. And that number is 1. 1 is known as the multiplicative identity. This is the multiplicative identity property. Some number times by 1 gives you that same number back as an answer. Which makes sense, and we all know that property. You take something times by 1, you get the same thing. Okay? In our integer rules chart, fill in the half that you know. You should know this first half right now. Go ahead, take a couple seconds, fill that out, pause the video if you need to, and then hit play when you are ready. Okay, so you should have had these you add, here you subtract, and then you keep the sign of the bigger number. All right. So those are the rules for addition. If the signs are the same, you add, the signs are different, subtract, and then you keep the sign of the bigger number. The rule for multiplication and division is you're going to multiply or divide like normal. But the signs change whether the answer is a positive or negative. So if the signs are the same, you're always going to get a positive answer. And if the signs are different, you get a negative answer. No, I think I was right the first time, then I. So you get a negative answer if the signs are different. So, for example, if you had a negative 3 times by negative 2, those signs are the same, you're going to get a positive answer. But if you had a negative 4 times by 6, those signs are different, you're going to get a negative answer. Okay? So let's see. Negative 3 times by 5. So you take the 3 times 5 like normal, which is 15. But then my signs here are different. Since the signs are different, you get a negative answer. Simple enough. 0.4 times by 3.5. So the way you do that is I set the longer number up top. You do not have to line up decimals. That is not important when multiplying. 4 times 5 is 20, carry the 2. 4 times 3 is 12, 13, 14. Now, with decimals, you count the number of decimal places in the problem. So there's one number after the decimal, two numbers after the decimal. It has to be the same in the answer. One number, two numbers, so the decimal goes there. 1.4. And the signs are the same, so it's a positive 1.4. Letter C. Well, we can just kind of multiply across, I suppose. There's actually an easier way. Let's do it the easier way. We're going to learn about a property in a couple slides known as the commutative property. Sound familiar? It's the moving property. I'm actually going to move this -4 right there. Watch what happens. Because I want to take the -2 times the -4 first, because that math's easy to do in my head. 2 times 4 is 8. The signs are the same. The answer's positive. Then I can take that times by 1.8, and I think it's just going to be a little bit easier. So multiplication has this commutative property as well. And we'll see that again in a couple slides. So here we have 8 times 1.8. So 1.8 times 8. Notice my decimals are not lined up. It makes no difference when you're multiplying. You just multiply. 8 times 8 is 64. 8 times 1 is 8, plus 6 is 14. Now, there is one number after the decimal in the problem, so one number after the decimal in the answer, which gives us 14.4, and the signs are the same, so it's a positive 14.4. Honestly, if you can do this decimal multiplication, that's probably the hardest stuff for the day. Letter D. Fraction math is much easier. With fraction math, all you do, so if we have 1/4 times by -12, you make both parts a fraction, multiply across the top, so 1 times -12 is -12, multiply across the bottom, and you're done. Now, we can simplify that. -12 divided by 4 is actually a -3, so this piece equals -3. And we take that times by 3, and -3 times by a +3 is 3 times 3 is 9. The signs are different, so the answer is negative. There we go. So we got ourselves a -9. Simple enough. So the rules basically are you multiply like normal. If the sign's the same, you get a positive answer. If the signs are different, you get a negative answer. When you're multiplying decimals, you do not have to line up the decimals. You simply set them up and down. You multiply like normal long multiplication, and then you count the number of numbers after the decimal in the problem. Here there were 2, so in your answer there needs to be 2. Here there was 1, so in your answer there needs to be 1. That's decimals. With fractions, if you're multiplying two numbers, and one of them is a fraction, make both of the numbers fractions. Then you multiply across the top, multiply across the bottom, simplify, and you're done. Okay, so that's a quick recap on all multiplication you're going to need for today. And here are 4 for you to try. Go ahead, pause the video, do these 4 problems right now. Hit play when you're ready to continue, or you need some help. Okay, letter E. So 8 times 2 is 16, and the signs are the same, so the answer is positive. 1.2 times 6. Decimals are not lined up. They do not need to be. 6 times 2 is 12. Carry the 1. 6 times 1 is 6. Plus 1 is 7. There is one number after the decimal in the problem. So one number after the decimal in the answer. So you get 7.2. The signs are different, so we get a negative number. Letter G. Let's see, multiply these first two. So you make this guy a fraction. Again, if one number is a fraction, make them both fractions. And multiply across the top, negative 5 times 2. Multiply across the bottom. Simplify. Negative 10 divided by 5 is a negative 2. And then we're going to take that thing times by 2. That's him. Come along for the ride. And negative 2 times 2. 2 times 2 is 4. Signs are different. Answer is negative 4. And lastly, letter H. We're going to take our negative 9 times by our negative 2. Negative 9 times negative 2 is 18, and the signs are the same, so it's a positive 18. Okay. And then negative 18 times by negative 1. 18 times by 1 is 18. The signs are different, so the answer is negative. Negative 18 times by negative 3. 18 times by 3. 3 times 8 is 24. Carry the 2. 54. And the signs are the same, so the answer is positive 54. Hopefully you had some success there. You got most of those correct. If not, well, we got some more practice throughout the rest of the lesson. For example, here are 3 more. These 3 come from the textbook, page 88, numbers 1 through 3. Go ahead, pause the video, do these 3 problems right now, and hit play when you're ready to continue. Okay, so let's see how we did. Well, 2 times 7 is 14. The signs are the same, so it's going to be a positive 14. Number 2, 0.5 times by 4. Well, 0.5 times by 4. Again, notice my decimals are not lined up. It doesn't need to be. 5 times 4 is 20. There is one number after the decimal in the problem, so one number after the decimal in the answer, 2.0, which is just 2. So that's the number part. Now for the sign. The signs are the same, so the answer is positive. Positive 2 times negative 9. Well, 2 times 9 is 18, and my signs are different, so the answer is negative 18. Number 3, 4/3 times by negative 3 times by 7. So let's make this negative 3 a fraction by putting it over 1. Now we multiply the top, multiply the bottoms, simplify. Negative 12 over 3. 12 over 3 simplifies to 4, and it's still negative. And a negative 4 times by 7. 4 times 7 is 28, and the signs are different, so the answer is negative 28. So now we've seen, what's that, 4, 8, 9, 10, 11 different examples of multiplication with integers, with decimals, with fractions. Okay? Next, we're going to talk about some of those properties. Now, these properties should all seem familiar. These are the exact same properties we had with addition, except now they're multiplication. So the first one here we have is this moving property. Do you remember the moving property's name was? It was the commutative property of multiplication. So the way I remember the commutative property is the moving is this word commute literally means to move. If you ever listen to the radio and they're talking about like, oh, the morning commute's going to be terrible today, there's lots of traffic. Well, that morning commute means people moving from one place to another. They're moving from their homes to their jobs. So it's the moving, commuting. Okay? Letter B. If you have some number times by -1, you basically just get the opposite of that number. This one's a little new. This is the property of -1. Basically what you're doing is you're taking the opposite of the number. Okay? Letter C. Now we're changing the grouping. Do you remember what the grouping property was also called? It's called the associative property. Now, you can remember that. If you ever heard the phrase like you're guilty by association, if you're out with some friends and your friends do something stupid and get in trouble, and you get in trouble as well, and you say, well, I didn't do it, but you're still in trouble, it's because you're guilty by association. You are guilty because you were associating with those people who are causing trouble. You're being grouped together with them. So associating is grouping. And this last problem, letter D, here we have something times by 0. Well, this is the multiply by 0 property. And you've learned that one since you first learned how to multiply. If you take anything times by 0, you get 0 for an answer. That's what that property says. Now again, I want to remind you why we have these properties. What these properties do is they can override the order of operations. They can actually let you do some math that when you first look at it seems impossible to do. For example, this problem. Here we have a -4x times by 0.25, and it does not tell us what x is. So you first look at it and you go, well, I can't do that problem. But because we have the commutative property and the associative property, which basically say if you have multiplication, you can multiply in any order and you're still going to get the same answer. So what we could do is we could actually rearrange this problem to say -4 times by 0.25 times by x, like this. Now, we can take this and we can do this math. 4 times 0.25 we can do. You can do it off to the side or on the back. 4 times 0.25. I put the longer number on the top. So 4 times 5 is 20. 4 times 2 is 8, 9, 10. And 2 numbers after the decimal. So that gives me 1. Negative, because the signs were different. So this piece here is -1. And then we have our x. So the whole point of those properties is it allows you to do math simpler. Look at this next problem. 2 times 19 times 5. Now, you could take 2 times 19, which is like 38, and then 38 times by 5 is some big number I don't want to do in my head. But if you're using these properties, watch this little trick. The way I would do this in my head is I would take 2 times 5. 2 times 5 is 10. And 10 times 19 I can do in my head. 1 times 19 is 19, and you add a 0, 190. That was made so much simpler because of those properties. Because I'm allowed to move numbers around and multiply in any order, and I'm going to get the same answer. Okay? I would like you to make an attempt at letters C and D. We are just simplifying. See if you can take that problem and make it look simpler. Multiply some stuff together that you're allowed to multiply. Go for it. And actually, we're going to change one thing. This M here, we're going to change it to an R. Okay, go ahead and try that out right now. Okay, so hopefully you did letters C and D. So what you could have found is, hey, I can take this -6 and this 5, and if they were together, I could multiply them. Guess what? Let's put them together. So we have -6 times by 5 times by R times by M. So this I can multiply to give me -30. 6 times 5 is 30. The signs are different. The answer is negative. Good. Then you could just add your variables back on, and it'd look like that. Or if you have R, M, same deal. Okay. When you're talking about variables and multiplication, you just put the variables, line them up, and it really does not matter the order. You still get the same answer. Letter D. Well, hopefully you saw, okay, I can take -2 times -6 and get a positive 12. And if you stop there, well, you're only halfway. We can take that 2 times that 7, that 12 times that 7 and get an answer as well. The 12 times this 7 here is 84. And then we have our times by z. So these properties allow us to make our problems simpler. Do math in our head. The last bit we have here is a couple wordy problems, some problems from the textbook, and we're done. So let's try these out here. These are all going to be multi-step problems. So the most important thing is understanding what the question is asking you to do. Write out a little verbal model if you need to, and then do your math. So it says here, James works at a fast food restaurant. He made $7.50 an hour for his first 40 hours. Okay, little hint. Anytime you have repeated addition, something that you'd be adding like 7.5 40 times, that's multiplication. So he had he made 750 times by 40 hours. Now, I don't know if this is exactly what I have to do, but it sounds right, and I'm putting down my thoughts. Okay, so for 40 hours times by that, that's how much money he would make in those 40 hours. Okay, continue reading. Then, because James was always polite, he got a raise of 20 cents more an hour for the next 40 hours. How much money did he make in those 2 weeks of work? Oh, okay. So this here would be week number 1. And that's what we want. We want how much he made in week 1, how much he made in week 2, and then our total of that. So week 1, he made $7.50 for 40 hours. Week 2, he made 20 cents more an hour. So he made $7.70 times by 40 hours. And if we do this math, that gives us our total. Okay. So we need to do some multiplication. Let me see if I can move this stuff slightly. Move this all over here a little bit. There we go. Give me some space to work. So I'm going to take 750 times by 40. So 750 times by 40, 0, 0. Drop down, add a 0. 20. 28 plus 2 is 30. So we got 0, 0, 0, 3. There is one number after the decimal. So this week he made $300. That's week 1. I evaluated 7.5 times by 40. Okay? Week 2, now he made 770 for 40 hours. 0, 0, drop down at a 0. 28 plus 28 and 2 more is 30. So 3080, one number after the decimal, gives us $308. So the total amount of money he made, 300 plus 308, is $608 for those 2 weeks of work. Does that answer make sense? I hope so. Everything looked okay to me. We took the total of week 1 plus the total of week 2, and that would give us how much money James made in 2 weeks. Week 1 plus week 2 is our total. All the math looked good. I think we're good. He made $608 in those 2 weeks of work. Okay? Let's look at letter B. It says here, a factory making cars for 3 years had an increase in sales by that many customers each year. Okay, so for 3 years, it went up by that much. So 3 years, we went plus 7680. Okay? Then the economy went bad for the next 2 years, and they had a decrease in sales by that much. Okay, so for 2 years, they had a negative 3,503 customers each year. What were their net customers for the 5-year period? Okay, so we want the total again. So if we have this much is the first 3 years, this much is the second 3 years, we want the total. So you got to figure out 3 years times by this gives us a total number of people, and then 2 years times by a negative 3,503, and then add them together. So that's our game plan. That's what we think we need to do. So let's do that. So I'm going to take, well, 3 years times by that. So 7680 times by 3, 0, 24, 18, 19, 20, 21, 23. So here we had 23,040 people those first 3 years. That's pretty good. Okay? Let's check out those second 3, or the next 2 years. So they had 3,503 times by 2, and this is a negative, which will come into play at the end. 2 times 3 is 6, 0, 10, carry the 1, 6 plus 1 is 7, and it is a negative because the signs are different. So for the next 2 years, they lost 7,006 customers. And we want to know what was their net customers for the 5-year period. So if we combine these numbers together, that gives us how many customers they had after those 5-year period. So let's see. I need some workspace. So we're going to take our 23040 and our 7006, and the signs are different, so we're subtracting. And we got a 4 and a 3 and a 0 and a 6 and a 1. So after those 5 years, they had a total of 16,034 customers still. Okay. Do you see how that multi-step problem worked out? We found what was the total for the first 3 years that was all positive, the total of the next 2 years that was all negative. When we combine those two together, we combined the positives and the negatives and figured out how many were left over, and we found there were 16,000 customers left over. And that's how we got our answer. We have one more similar problem for you to try. I'll read it here. It says, from 1900 to 1940, a 250-foot wide crater was eroding at a rate of 0.02 feet per year. And notice it's a negative because it's going down. From 1940 to 2000, it was eroding at a rate of negative 1.2 feet per year. Again, negative. Approximate the width of the crater in 2000. Okay, so go ahead, pause the video, see if you can find out how big this crater is now. Okay, so here's my verbal model. So I have from 1900 through 1940 width. That's the first part I've got to figure out because this has its own little piece. It was 250 foot wide, and then it was eroding by this much. So every year in this time span, in this 40 years, it was getting bigger by 0.2 feet each year. And then from 1940 to 2000, it got wider faster, this 1.2 feet. And I want to know what is the total width of the hole now. T-O-T-A-L, total. All right, so this is 40 years times by 0.02 feet each year. This is 60 years times by, man, I didn't have a space for my negative, times by negative 0.12 feet each year. And that would give us our total. Okay, so let's see here. 40 times by a negative 0.02 gives us, I don't know, I need some space to work. New page. You got space on the bottom of your paper, you can work this one. So it's 40 times by a negative 0.02. Negative 0.02. Alright. So 0, 8, blah, 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 negative. Now there are two numbers after the decimal in the problem. So there should be two numbers after the decimal in the answer. So over those 40 years, the distance was negative 0.8 feet. Okay, so let's put that back in our problem. So in these first 40 years, the change was a negative 0.8 feet. Okay. Now what about in this 60-year period? In that 60-year period, it was negative 0.12 feet. So that's 0 and 12, drop down out of 0, 0 and 6, 0, 2, 7. Negative, there are 1, 2 numbers after the decimal, 2 numbers after the decimal. So we got a negative 7.2 feet. Alright, so let's see if we understand what we have here so far. In the first 40 years, the change was this 0.2 feet each year. So we took the change times by 40 to get the total change over that 40-year period, 0.8 feet. Then over the next 60 years, the change was 0.12 feet each year. So we took the 0.12 times by the 60 to get the total change over the 60 years, negative 7.2 feet. So now if we combine these numbers together, we will get our total change in the width of this crater. So 0.8 feet plus negative 7.2 feet, the signs are the same, they're both negative, gives us a negative 8.0 feet. So the width of this crater changed by a negative 8 feet. So let's see. If it was 250 and it changed by negative 8 feet, that means the crater is now 242 feet across. It was 250. The change was negative 8 feet. So 250 changed by negative 8, which means it's going down by 8. It's now 242 feet. Boom. Was that a pretty involved problem? Yeah. You had to write out your verbal model and make sure you had a good verbal model. You had to understand that in your verbal model that this was 40 years and you had to take 40 times by how much the change was each year. And then the same thing for the 60, and you found the total change in feet. Then you said, okay, well, if the change was negative 8 and it started at 50, so 50 and changed by negative 8, so it's now 242. Hopefully that makes sense to you. The last thing we have here, you're going to need some space because we have a couple problems here. Comes from page 89 and 90, numbers 4 through 13. Now, before you go too fast, look at 4 through 9. They just say identify the property. It does not say multiply. So here you are just identifying the property. Very quick. The next say find the product, which means you multiply. And for number 13, it says use the data in example 4. Here is the data from example 4. Okay, so it's not the same problem that we did a second ago. This is a problem from the textbook. So go ahead, pause the video if you need to, do it now, and we will go through them together in just a second. Okay, hopefully you're done. If you're not, then go back, pause the video, and work some more. Number 4, property here. Well, we're multiplying by negative 1, so this would be the multiply by negative 1 property. Number 5, let's see. From one side of the problem to the other, they are just switching the numbers around, so this is commutative property. Number 6, they're changing the parentheses, so they were around the y and the 4. Now they're around the 4 and the 9, so that's the associative property. Number 7, they're taking something times by 0 and getting 0 for an answer, so that's the multiply by 0 property. Number 8, they're just switching the numbers around, so that is commutative again. And number 9, they're multiplying by this negative 1, so it's the multiply by negative 1. So that's all that was there. Those first 6 were just identifying the properties. Numbers 10 through 12, we're going to involve a bit more space. So let me go like this. Ooh. All right, 10. So we're taking 3/10 times by 5y. Okay, so we're simplifying this as much as we can. Well, we can't take 5 times y because we don't know what y is. But if we could, I'd like to take the 3/10 times by the 5. And we can. We can simplify that. We take the 5, put it over 1, because these are all multiply. We can multiply them in any order. So I multiply across the top, multiply across the bottom. Don't forget about your y. And now, simplify. 15 over 10 does simplify into 3 over 2y. And you know what? We can leave it like that. We could actually leave it as 3 over 2y. We don't need to change it into a mixed number. Number 11. 0.8, negative x, negative 1. Well, if this negative x wasn't here, I could multiply 0.8 times negative 1. So maybe if I move around a little bit, I can move the 0.8 next to the negative 1. Oopsie. And then negative x goes at the end. So I can multiply this and then that. So here, 0.8 times by negative 1 is just a negative 0.8. And then we're going to take that and this negative x, little trick, something you're going to see a lot throughout the year. Anytime you have just a negative in front of a variable like that, it means it's negative 1 times the variable. So we've got another negative 1 here. So we have a negative 0.8 times by a negative 1 times by x. So if you're taking times by negative 1, it goes back to a positive 0.8 and x. I did negative 1 times by negative 0.8 is positive 0.8. And 12. Negative y, which again, remember, there's a negative 1y. If you want to throw the 1 in there right now, go for it. Times by negative 0.5 times by negative 6. And that negative 1 up there looks sloppy. It looks like a plus y. So make it a negative 1y. There we go. So I'm going to multiply that first, because I want to multiply my numbers together. So 0.5 times by 6. If you did the work off the side of your paper, good job. Hopefully you got an answer of 3. Positive 3. And then you take negative 1y times by 3, but my numbers are on different sides of the variable. So I'm going to move my 3 out front. I'm going to commute it. So now I have 3 times by negative 1 times by y. I can do that math and get a negative 3 times by y. So these were all major uses of those different properties we learned of multiplication. I would not get too bent out of shape if you really didn't understand them. It's good to know those properties exist, but the way they're used here in these problems are not how they're typically used a lot in math. Typically, the places we're going to use those properties are kind of like behind the scenes problems, where you really don't know you're using it, but you are. But it's good to know the properties exist. I'm going to erase this stuff to do number 13. Okay, 13 says, use the data in example 4, which is here. Approximate the elevation of Mono Lake in 1925 and in 1965. Okay, so we've got to do the problem twice. We've got to find out what is the height of the lake in 1925, and then what's the height of the lake at 1965. Okay, so let's do 1925 first. So it says in 1900, the elevation of Mono Lake in California was about that. Okay, so 1900, that was the height, the elevation. From 1900 to 1950, the average rate of change in elevation was about that much per year. Okay, so every year in this range, the elevation of the lake went down by 0.12 feet. So we want to find the height at 1925. So we're going to have 25 years of it going down by 0.12 feet. Right? 25 years, because from 1900 to 1925, that's 25 years. And every year it's going down by this much. So let's do that. I'm going to work over here and erase it eventually, but we'll need this space too. So work further down the page, off to the side, someplace if you got space. But I need to take 25 times by 1.2 or 0.12. 25 times negative 0.12. That's 10. Carry the 1. 4 plus 1 is 5. Drop down. Add a 0. That's 5. That's 2. 0. 10. Carry the 1. 3. There are 2 numbers after the decimal in the problem, so 2 numbers after the decimal in the answer. The signs are different, so the answer is negative. So the height went down by 3 feet. Get it? height went down by 3 feet. So if it was 6,416 feet and it went down by 3, it is now 6,413 feet in 1925. Good so far? All right. Now it wants us to find the height in 1965. Okay, so we're going to need to do some of this math again because we got to figure out what is the change from 1900 to 1950. And then from 1950 to what's the question? 65, at the change was about almost half a foot a year. Okay, so hopefully you have your answer here for 13. This part here, because I'm going to erase it. I need space to work. All right, so from here to here is 50 years times by negative 0.12. So this is the change in feet in this 50-year period. Here, this is 15 years times by negative 0.526 feet. So this is the change in feet over the next 15 years. And together, that gives you the total change from 1900 to 1965. Okay, so let's do this part first. We're going to take 50 times negative 0.12 gives us 0 and 10. Carry the 1. Drop down, add a 0, 0, 5, add it up, 6, 0, 0. 2 numbers after the decimal in the problem. 2 numbers after the decimal in the answer. The signs are different. The answer is negative. So in this range, it went down by 6 feet. So in those first 50 years, it went down by 6 feet. The next 15 years, it went down by, I need more space, I think. I'm going to put the 526 thing up top. 0.526 times by 15. I like putting the longer number on top, the one that has more digits on top. That's just my personal preference. So 5 times 6 is 30. 0, carry the 3. 10, 11, 12, 13, carry the 1, 25, 26. 6 and 2. Drop down, add a 0. 1 times 6 is 6, 1 times 2 is 2, 1 times 5 is 5. Add it up, 9, 8, 7. There are 1, 2, 3 numbers after the decimal in the problem. 1, 2, 3 numbers after the decimal in the answer. And this 0.526 is negative. So the signs are different. The answer is negative. So now we've found the first unit of time, it went down by 6 feet. In the next 15 years, it went down by 7.89 feet. So we want to find what is the total amount the lake went down. So so we got negative 6 and a negative 7. I did not line up my decimals properly. Negative 7.89. The signs are the same, so we're adding. So the total change in that 65-year period was negative 13.89 feet. The question was not what was the change. The question was approximate the elevation of Lake Mono in 1965. Well, that means we got to find the change from how it started until 1965. So it started at the 6,416 feet. It went down by 13.89 feet. What is our total? I'm going to have to write it out someplace and do it. 6,416, 13.89. Subtract it. Notice how I have my decimals lined up. Borrow 5, 10, 9, 9, 2, 2. There's a decimal there. 1. Oh, that's a 0. 6 and 4. So the new height of Lake Mono in 1965 that we got after we did this little subtraction was 6,402 feet, 0.29 in 1965. So it's the same idea of the problems we were doing before, just a little bit more. And we don't have to do this because that was the original problem from example 4. So, summary. How do you multiply real numbers? What do you do? What rules do you use? Go ahead, pause the video, write down an answer, and we'll get back together in just a second. Okay, here's what I came up with. I said multiply the numbers like normal. Then, if the numbers have the same sign, the answer is positive. If the numbers have a different sign, the answer is negative. That's basically what we said in our integer rules chart here. Signs the same, positive, signs different, negative. And last but not least is homework. It comes from page 91. Numbers 3 through 51, multiples of 3. Again, those are like 3, 6, 9, 12, those problems. Okay, this has been lesson 2.4. Thank you for watching.